Ever wondered why some solutions taste stronger, react faster, or look deeper in color? It's all about concentration. Let's decode the secret behind every drop of chemistry magic. Concentration is the amount of solute dissolved in a solvent or solution. It indicates how much solute particles are in a given solution. A concentrated solution contains a high amount of solute, therefore the solution has more solute particles. A dilute solution contains a low amount of solute, therefore the solution has few solute particles. Molarity, also called molar concentration, is the number of moles per liter or cubic decimeter in a solution. The formula for calculating the molar concentration is molar concentration is equal to mole of solution over volume of solution, or simply C is equal to N over V. Let's consider some examples. The first example, calculate the concentration of a solution containing 15 grams of sodium hydroxide dissolved in 0.3 decimeters cubed solution. Molar concentration is equal to mole of solution over volume of concentration. First, we calculate the mole of sodium hydroxide from the given mass. Mole of sodium hydroxide is equal to mass of sodium hydroxide over molar mass of sodium hydroxide. The mass of sodium hydroxide is 15 grams, and the molar mass of sodium hydroxide is 40. This gives 0.38 moles. Then molar concentration is equal to 0.38 over the volume of solution, which is 0.3 decimeters cubed. 0.38 over 0.3 gives 1.25 moles per decimeters cubed as the molar concentration. The second example, calculate the molarity of a solution prepared by dissolving 32 grams of potassium permanganate in 500 centimeters cubed of a solution. Molarity is equal to mole of solution over volume of concentration. First, we calculate the mole of potassium permanganate from the given mass. Mole of potassium permanganate is equal to mass of potassium permanganate over molar mass of potassium permanganate. The mass of sodium hydroxide is 32 grams, and the molar mass of sodium hydroxide is 158. This gives 0.2 moles. Then molar concentration is equal to 0.2 over the volume of solution. The volume given is 500 centimeters cubed, so we divide by 1,000 to get 0.5 decimeters cubed. So the volume of solution is 0.5. 0.2 over 0.5 gives 0.4 moles per decimeters cubed as the molar concentration. The third question, calculate the number of moles in 100 centimeters cubed of 1.5 mole per decimeters cubed of sulfuric acid. The moles of sulfuric acid is equal to molar concentration times volume. The molar concentration 1.5. The volume of solution given is 100 centimeters cubed, which as to be converted to decimeters cubed, we divide it by 1,000 to get 0.1 decimeters cubed. 1.5 times 0.1 gives 0.15 mole, as the moles of sulfuric acid. The final examples. How many grams of potassium nitrate will be required to prepare 800 centimeters cubed of 1.4 mole per decimeters cubed of potassium nitrate? To find the mass of potassium nitrate, we need to find the moles. Moles of potassium nitrate is equal to molar concentration times volume of solution. The molar concentration is 1.4, and the volume of solution given is 800 centimeters cubed. This has to be converted to decimeters cubed by dividing with 1,000, and it becomes 0.8. 1.4 times 0.8 gives 1.12 mole as the moles of potassium nitrate. Now we can calculate the mass of potassium nitrate. Mass is equal to moles of potassium nitrate times the molar mass of potassium nitrate. The moles of potassium nitrate is 1.12, and the molar mass is 101. This gives 113.12 grams as the mass of potassium nitrate required. To recap, concentration is the amount of solute dissolved in a solvent or solution. A concentrated solution has more solute particles. A dilute solution has few solute particles. The formula for calculating the molar concentration is molar concentration is equal to mole of solution over volume of solution. Every reaction's strength depends on how concentrated its ingredients are, because in chemistry, precision isn't optional, it's the law of matter itself. Now that you know how to calculate molarity, in the next video, we'll explore dilution formulas, how to make strong solutions weaker without changing their chemistry. Stay tuned. Stay curious.